is to introduce a particle system to handle the breakup of our building. Now we'll do this first before we start dealing with the dust system, so we get this guy baked into our scene first. Now couple of things we need to basically concentrate on here. One is we're going to have to use a system for each individual set, i.e. each individual layer that we've got set up in here. So we'll do one system for this, one system for that, one for that, and one for that, and we will run the simulation for each one in turn. The reason being is because each one does not interact with the next. Like I said, there are no dynamics within this scene, even though the system will look like the geometry is kind of interacting with each other. It actually physically isn't. So we can run the simulation for each one of these in turn, which will basically save time and issues in the long run. Okay, so at this particular stage, with everything kind of set up, I'm going to go and save my scene. So I'm going to save that as barn tornado. I'm actually going to save that as finished. So I'll constantly overwrite this guy so that you've actually got this scene with this tutorial at the end of the day. Okay, so what I basically need to do is I need to set up a system initially that's positioned within the center of this barn. Now remember what I was saying about the reference within the, because of the debris formation being explosive, so it's basically going to peel off what's going to explode outwards and then get caught up within the tornado. So we need a kind of directional force, because if the vortex space warp catches it, it's simply just going to get dragged straight into the vortex, which is obviously going to make the geometry pass through other adjacent pieces of geometry, which obviously is not going to look real. So therefore we need to have like an explosive out force, which is then going to get lifted and caught up within the vortex. So to do that, we can basically cheat the system by setting a particle flow source icon directly underneath the building, and then using from icon center outwards to set initial speed of the particles. So therefore they're basically going to be, if the icon's down here and the center pivot point's down here, the particles will basically travel away in this kind of direction outwards. So we get this kind of faked explosive motion of our building explosion. Alright, so to do that, what we need to do is to, in our top viewport, switch across to there, I'm just going to go across to this create tab here and then pull this menu down and choose particle systems, and I'm just going to choose this PF source and just drag one out here like so. Okay, so what I want to make sure is I've got the quantity multipliers set all the way up to the top, so that's at 100%, so we're seeing exactly in the viewport what we will get at render time, even though we're only going to be dealing with baking the simulation in here. So, but we want to see 100% of the particles just to make sure the system is working correctly. System management, I'm also going to set the particle amount upper limit to its top end value, which, as I'm dealing with a 32-bit system in this particular instance, is 50 million particles. The integration step I'm going to set to frame for the render as well, so again making sure that everything is exactly the same. We might not use that, but it's always good to make sure that we've got both for this kind of system. Okay, with that set up, I'm just going to scoot into particle view and we'll go through and start setting up our base system. Now what we basically need to understand here is, like I say, we're going to deal with each one of these guys in turn. So I think at this stage what I'll do is I will hide everything apart from the posts and beams. We'll start at the bottom, i.e. the heaviest items, and we'll work our way out. So therefore I'm just going to hide all of these guys. I'll even hide this left standing as well, because obviously we're not actually going to affect these. This is not going to be dealt with with a particle system. It's all this kind of underscore listed layers here which are going to be affected by the particle system. This guy isn't, nor is anything in here. So this is the one that's we're dealing with at this present time. So just going to drag this guy across here. What I want to do is I want to rename this system. I'm going to call that PF source posts. Okay, and then I'm simply going to go through and I'm just going to bin that entire event. Alright, reason being is because I want to set up some initial properties of my own. So I want to use a birth script in this instance. The reason being is because I want a single particle for every single piece of geometry here. I don't want any more, I don't want any less. I want the exact amount of particles, and I want the particle to be positioned at the pivot point of every single piece of geometry. Okay, so what I want to do is wire the output of this guy into here, and I'm going to rename this event. Let's call that posts placement. Alright, and I'm going to choose this birth script, and I've actually got the script already established and included with this tutorial. So what I'll do is I'll load it in, and I'll go through the script stage by stage to explain exactly how it's constructed. So what I'll do first actually is I'm going to clear all of this lot out, because if we open the script it will actually append it to the one that's already in there. So I'm just going to make sure this entire birth script is clear, and then open this guy, and I'm going to load in the it's this barn tornado particle position birth.ms file. So it's this guy here. Now what this script actually does, like I say, it positions a particle for every single piece of geometry in here. Obviously it's not working at the moment because we need to basically tell the object names, tell the script the actual object names that we basically want to introduce, which I've obviously highlighted in here. So just as a side note, this script was originally developed by a guy called Borislav Petrov, also known as Bobo. So I would seriously suggest, if you haven't already, jump across. So this is his website. So I would seriously suggest you jump across there. Some really nice information on particle flow and how to script. So I would seriously suggest you jump across there and have a look at some of the content. So what we basically need to do is, like I say, go through and replace the array names and also this guy here, which basically references the object names within the scene. So let's go through the script to basically describe what it actually does. So we're basically saying, okay, right, we need to obviously create new particles, so therefore we need to set the particle age in there. So in essence we're going to be setting the particle age to 0, and we're also going to be referencing the transformation matrix of the particles within the system down here, so therefore we need to enable that within the system as well. So this basically enables us now to define a global array and then reference all the objects which basically start with a specific name. The star is basically a suffix that it calls on. So for example, you've got like box 1, box 2, box 3, box 4, anything that's basically called box, and then a number, for example, afterwards will all get called into the array. So basically what it does is it simply loops through the amount of times a piece of geometry exists, i.e. say for example we've got like 100 pieces of geometry here. It loops through the system 100 times, adds a particle to it, sets it, gives it an index which is equal to the particle numbering, sets the age to 0, and then sets the transformation matrix, i.e. its position in essence, to the pivot point location, which is basically this transform value that calls on, that's called within the array, that references the object. So in essence it's basically saying, okay, this one gets loaded in, say one object gets loaded in, passes through the system, assigns a particle to it, assigns a index, i.e. a number to it, and then loops up round for the next one, and so on and so on and so on until the entire lot is done. And then by the time it gets through that event, which is this guy here, it will then display the particles as ticks. So what we need to do is we need to obviously replace this header here and this guy here to reference the geometry name in the scene. And if I just select on this guy here, what it's actually called is posts beams. Alright, so we need to basically change this name here to posts beams. So this is, like I say, this could actually be called anything you like at the end of the day, as long as it's the same as what it is down here and here. But this guy does need to be exactly the same as this. So because it's obviously lowercase down here, we need to make sure it's lowercase in here as well. So I'm going to call that posts beams, and obviously the start references any suffix in here. Obviously we've got the suffix of 169 in here, and then this guy I want to make sure it's the same capitalization as and lowercase lettering as in the array name here. So capital P O S T S beams array dot count, and then one last time in here. So posts beams array. Okay, so that's that guy sorted out. So once I close this, so now we've basically got a particle for every single piece of geometry in the scene. If I just switch across to perspective, and let's just grab one of these guys in here. So now we can see that we've got a particle for every single one that's in the location of every single pivot point of every single piece of geometry within the scene, within this destroy building posts and beams layer here. So every single one of those guys has got a particle assigned to it. Okay, that simply just positions the particles. We are not affecting the position of the geometry yet. That basically comes later on when we actually start adding in a scripted operator in a sec. Now what we'll do first is we'll actually set up the motion of the particles, and we'll test those out first before we actually introduce the scripted operator, which will bake the motion into the actual scene. Okay, so first thing we need to do is we need to introduce a force space warp in here, and this guy is going to simply load in the vortex posts, okay, which is going to be this guy there. So what that basically does is that when it actually gets within the boundary, if I just scoot to the top viewport here and just pull that back and animate that forward, you can start seeing these guys moving. Okay, so that's all fine, well and good. However, we obviously want to introduce wind in here as well. Now the problem being is that if we introduce wind at this particular stage, the geometry is obviously going to start distributing straight away. So what we want to do is, once these guys have started moving, we then want to introduce wind and everything else. So what we can do is we can have this force space warp in here and then check for speed to make sure that, well, to see whether or not these particles have actually started moving, because none of them have started moving until about this particular point. Okay, we can have them sitting all within this event, alright, and then have this next event dealing with additional forces like wind, and also start baking out the system. Okay, so we don't have to bake any positional information of the geometry until they actually physically start moving, which will basically save calculation times. Okay, so to do that, what I'm going to do is add in a speed test here, and within this particular test, what I want to do is I want to set this is greater than test value to a really low value of, say for example, of 1. And then all I need to do is to basically drag out a spin operator to the canvas to create a new event, and then I'm going to actually label this guy, let's call it posts rip out, because that's basically what it does at this particular stage, and then wire the output of this speed test into the input of this guy here. Okay, this one I actually want to reduce the amount of rotational, well, the rotational spin down to a value of 100 with a variation of 100 in there. Okay, so if I just click off here so we can see these in the viewport, so you can see that they won't get past to this event until the force space warp, which is obviously the boundary of this guy, starts affecting it, which is going to be around about there. So you can see them turn pink, but they're not moving a great deal, quite simply because they have only got, in essence, one integration step, which is basically one frame to set them moving. So the force is not having that much effect on them overall, because obviously they as soon as they actually start moving, they'll pass straight to this event, so the force is no longer being affected at this particular time anyway, because obviously we'll introduce it back into this guy down here. Okay, so because we want this explosive action, okay, what we need to do is we now need to add in the speed operator, and that can just get dropped in there like that. And what we need to do is, like I said previously, is set it to icon center out. Alright, but we don't need, as you can see, we don't need it that vigorous. What we can actually do is set the speed to a value of 40 with a variation of 40 as well. Okay, and just to add a little bit of additional random variation in there, we can set the divergence to 10 as well. So when we scrub through, you can see this kind of exploding outwards like this. If I just switch to camera, we can see this guy going out like that. So this is going to be the motion of our posts. Obviously we need them to obviously bring back down again, which is obviously going to be requiring a additional space warp in our scene, which is obviously going to be gravity, which we'll introduce in a second. Okay, so that's that setup. The next thing we need to drop in is a well, we'll drop in the I think we'll drop in the winds at this stage. So let's drop in those by dragging in a force operator in there. And then what we'll do is, for this one, we need to add in the wind dust. So let's grab that. And we'll also add in the vortex posts, which is that guy there. Alright, we don't want the influence to be that high, so we actually want to set that at 500%, which in essence is half of its original value. So therefore what we've got now is this motion. Okay, bear in mind that these guys are pretty heavy, so we don't, if you notice that these guys are basically being blasted upwards, we don't obviously want them to be obviously travelling up like they're light as a feather, so we need to now introduce gravity obviously to bring them down. So obviously bear in mind that these guys are pretty heavy at the end of the day. So you'll notice that before we actually started bringing these through, they got swirled around once and then pretty much dumped. That is pretty much right. That's pretty much what we want to achieve at the end of the day, because like I say, these guys are pretty heavy, so this tornado is not going to pick them up and swirl them around like this. They're basically going to just get flung around and then hit the ground straight away. Okay, so to do that, what we need to do is add in a force space warp in here, and we need to obviously introduce gravity to the system as well. So I'm just going to get this gravity space warp here and just drag this guy out, and simply drop this within our new force space warp here. So when I scrub through, it's going to go straight down. So obviously our influence value is a little bit too high at this present time. So therefore what I want to do is obviously set this influence value down to, I'd say, about 100 or even 70 maybe. Let's just get these out of the way here, so we'll actually start seeing these guys falling. So I'll drop that down to about 100. Actually, yeah, I think we'll take that down to about 70. So we got these guys. Actually got a redraw issue in there, I think. So I think I'll turn this guy off and then scrub through. There we go. That's kind of what we want to see. So being flung out, they'll spin around a bit thanks to this guy here, and then they'll kind of get dumped. Okay, so that's the posts one pretty much set up. We also need to, well, the posts motion, initial motion anyway, set up. Now you'll notice that they are going to go and pass straight through our ground plane here. So what we need to do is introduce the deflector at this stage, and by that I'm going to drop in the deflector in there like so. So when they fling around, they bounce and then come to a rest almost immediately. So they may bounce once or twice, if that, but because of the friction that we introduced earlier on, then they are going to basically come to rest. Okay, so when they actually hit the deck, we actually want some of them to, in essence, impale straight into the ground, like I mentioned before. We don't want all of them to bounce around like, you know, like ping pong balls or anything like that. Well, they're not exactly bouncing around like ping pong balls, but we don't want them to kind of all go, you know, with the same kind of uniform bounce across. We want, like I say, some of them to hit the deck, and we also want some of them to, when they actually hit the deck, to have a different spin on them. So therefore, when they actually hit the ground, we want them to basically spin in a faster motion. Okay, so I think first things first is we'll introduce a split amount test to the canvas, and then this one I'm actually going to rename and call that posts collision. Alright, and then wire the output of this guy into there. So we can set that 50%, actually leave this value as is, will get piped to another event which will kill the speed and the rotation of the particle. So therefore when the particle hits the deflector, they will suddenly stop, and the rotation will obviously stop as well. Well, the spin will stop actually. However, in this guy, what I want to do is I actually want to set another spin in here, and this one I actually want to set with a value of let's say 150, with a variation of 150 in there as well. Even though it says in here 149, it's actually 150. It's obviously like a redraw or a bug issue that's reported back here, so it is actually 150 and 150 in there. Okay, the vortex and also the gravity needs to be brought across to this. Now, once it's obviously hit the deck, I don't want the winds to affect it anymore. What I want to do is I can just copy this guy up here and then bang that in there. Okay, and then same kind of principle here as well. I can copy that and then instance that in there as well. Alright, same kind of principle. So when we actually scrub through, we want to make sure that the particles interact with the deflector again. So obviously I need to copy this and instance that across to there. Okay, so this time when the particles hit the deflector again, I actually want to stop them. So they'll bounce once, and when they actually hit for a second time, if you'll notice that they almost stop on the second bounce anyway. So if you'll notice some of these guys here around about here, when they hit the deck once and then twice, maybe about after the third time, they actually stop fully. However, I think we can improve on that and just have it so that when they hit it once, it goes into here, and then when they hit it again, what we're going to do is do exactly the same as what we're going to do with the guys that get split out of here. We're actually going to kill the speed and kill the rotation. So the spin operator will drag out to here, and we'll label this event. Let's call that posts kill speed and rotation. I've actually put an N for and in there quite simply because an and sign does not appear. It actually redraws it as an underscore, so I'm actually going to stick that as an N in there. Bad grammar, but there you go. Okay, so what I want to do is wire the output of this guy into there, and wire the output of this guy into there as well. I'm actually going to pull that across there so we can see what's going on. Alright, so this spin, I want to set the spin rate down to 0 by right clicking on this guy, and the speed, I'm going to drag that in there and then set this guy to 0 as well. So that basically will give us the opportunity to kill the speed of the particles and kill the spin. However, bear in mind what I said earlier on. We obviously want the particles, if they appear in front of this funnel, okay, if they basically get flung out and dumped over here, we obviously want them to be picked back up again. So how did we actually check to see whether or not they were moving earlier on? We used this force space warp, they used this vortex space warp within this force operator here, and we used this speed test. Okay, so same kind of principle as before. We can simply just copy these guys and then instance them across to there. Let's put that up there. So then that will basically test to see whether or not they are moving again, okay, after they have actually been killed. Alright, so the speed is killed first, and then we are testing afterwards. Alright, if this basically was above there, the test will be done before the speed will be killed, so therefore they would come out as true and therefore get passed to the next event, which is obviously incorrect. Okay, so what we need to do now is we need to create one more event, which is in essence going to be pretty much an instance of the previous event, which is going to introduce the we're going to have some spin in there. We're going to introduce the vortex posts back in there as well to obviously keep them rotating, and put the gravity back in as well. Okay, so just for safety, what I think we'll also do is drop in this deflector into this post-kill speed and rotation in there as well. Now obviously because they are obviously static, they're not going to be affected that much. However, we obviously need to make sure that the force space warp, the force operator here with the vortex space warp in here, does not accidentally push them beneath the deflector when they start moving again. Okay, so we need to make sure of that. So I'm just going to drop that guy underneath there. Okay, so the next thing we need to introduce is when they obviously start moving again, the particles need to be passed to another event through this speed test. Okay, so actually what I think we'll do is we need to get these guys to lift off the ground a little bit when they start moving again. So I think we'll actually drop a speed operator in here, and this one I'm going to set to a long icon arrow, and that at the current time the icon arrow is actually pointing downwards. So what I want to do is I want to make sure that the particles are actually traveling in the right direction. So this time I'm going to set the icon direction to reverse, and I'm going to set the speed to a value of 30 with a variation of 30 in there as well. So actually, you know what, I think I'll turn this guy off, and I'm going to rotate this just so we can show that they are traveling in this direction. Okay, so I'm going to rotate this guy 180 degrees like so. Okay, so I can now make sure that that guy's off, and I'll wire the output of this into here, and I'm going to rename this guy. Let's call that something obvious. Let's call it posts moving again, because that's what it pretty much is. Okay, so what I want to introduce now is another spin operator, and that is to obviously get them to start spinning a little bit, well, maybe a little bit faster than what they were previously, as they're starting to shift again because they've been dragged and then have been kind of caught up again. So I'm going to set the spin operator that I'm going to drag in here. I'm going to set that spin rate to, let's say, about 200, with a variation of 200 in there as well. Okay, obviously need to have the vortex in there too, so I'm going to copy that and I'm going to instance that across to there. I'm just going to drag that across down to there, and obviously need the gravity to be brought back in as well, so I'm going to copy that and then instance that in there as well, because obviously we need them to come back down to Earth again as well. Now, same kind of principle as before, we need to make sure that when these guys hit the deck a couple of times, they are basically stopped. So to do that, what I'm going to do is I'm going to drop in, actually what I can do is I can just copy this and I can basically just paste it in here just by dropping that guy in there like that. So obviously I've got this as a copy. However, what I'm going to do is I'm actually going to change this so that it's allowed to bounce multiple times, and the only amount of times it's allowed to bounce is going to be a couple before it gets its speed and rotation killed. So therefore I'm just going to drag that across to there, and I'm going to wire the output of this guy into here. I'm just going to pull that across a touch so it doesn't interact with this guy here. Now, one last thing I want to do is I'm simply going to check for speed as well, because the first collision, depending on how fast these guys are actually traveling, they might be just skimming along very, very slowly. So therefore what I can introduce is another speed test in here. So this guy is going to be copied and then just pasted in there, not instanced again, just pasted in there. And then this time I'm actually going to say, alright, test true if particle value is less than, let's say, a value of let's say a value of 2. Okay, so therefore the particles are picked up again in here by this guy. If they are faster than a value of 1, they are basically sent into this event where we've got a speed assigned of 30, a random spin applied, they're picked up by the vortex, dropped down to Earth by the gravity, and then tested for speed to see whether or not they come to a virtual rest or if they've bounced more than a couple of times. So either or, they then get piped back into this speed killer here and then are sat at rest until they are perhaps again picked up again and then picked and then dumped back into this event as well. So let's just quickly run through this system to see what we've got. I'm just going to click off there so we can see the particle colors. So the particles are then picked out of the posts and then swirled around, dumped on the ground, bounced once, maybe even just hit the deck and gets implanted straight away, like some of these guys, and then let's have a look in the top viewport what we've got. So they get picked up, swirled around, and then dumped. You notice this guy over here, if we actually extended the length of this animation, it might even get picked back up again and then swirled back around again. So you'll notice that actually you can see one of these guys here have actually made it into this event. So we just pull that around there. So you can see that guy has been actually dumped and then picked back up again as well. Okay, so that's pretty much our posts system set up, apart from the fact that we obviously now need to introduce the baking into the system. Now at this stage I would seriously suggest that you save the system, okay, or save the scene, and then we can introduce the script operator. Now there's only certain places where we need to introduce a script, and that is going to be within the post rip out event, the collision event. We don't need any sampling or any baking within the event where the particles are obviously at rest, but we obviously need to have the script within the where it's moving again. So what we can do is just create one script and then instance a script operator across the well, 1, 2, 3 events. Now the script needs to be actually positioned towards the end of each event, bearing in mind that particle flow is event driven, so therefore the particle comes into here, goes through this, then this, then this, then this. Then we basically need to check, well, we need to bake out the result of these guys before the collision is tested. You always want the collision to be basically at the end of the event, because otherwise if a particle is moved or its properties amended, then the collision may fail. Okay, so a lot of times we get a lot of questions from people saying, okay, we're getting a lot of collision particle leakage. The reason being is because your collision is actually positioned up here, so you need to make sure that it's obviously down here. Okay, so to do the baking, what we need to do is introduce a script operator in here. Alright, so again I'm going to make sure that it's actually positioned above this collision, and this guy, what I want to do is click on this edit script button, and same kind of principle as before. What I've done is actually include the script with this tutorial, and it's located here, which is the Bar Tornado particle baker. So for this one, same kind of idea as before. It's simply a case of this guy goes through, we're using the P-can't use time, use transformation matrix. We load in every single object as before with a suffix into an array, loops through the system several times, and what it basically does, it compares the particle index with the relevant object in the array, and then moves the object, so move the object in the array, its transformation matrix, i.e. its XYZ motion coordinates or position coordinates, to match the particle transformation coordinates, i.e. the position of the particle. So in essence, for each frame, for each particle, we are moving its corresponding object. Okay, so what we need to do is obviously go through the script and amend these the array and the variable names. So what I want to do is just change this here, and I'm going to label that move posts beams array, and I'm going to change this to obviously the same name that we used previously, which is posts beams, because that's the name of the objects, making sure you've actually got obviously this the same as in here. Okay, this, well, obviously this guy needs to be replicated all the way down here, so let's drop this guy in here, so it's posts beams array, so obviously that is the same as that. Okay, and then that is pretty much it. So what we're basically doing, like I say, at each single frame we've got animate on, which is in essence auto key. So in essence it's turning auto key on itself and then moving it for every single frame. Okay, and then in essence baking out a keyframe for every single object. Now this is important. Now we've got this thing set up, alright, before you close this, make sure you are at frame 0. Okay, very, very important. If you close this now and you're basically, say for example at frame 80, it will bake the system. So the reason why I said to save the system out before we started doing the script, if you do not do this at frame 0, chances are that it will bake the particles into the geometry, i.e. the geometry motion will be baked into the scene. If that actually happens, chances are if you scrub forward and scrub backwards, it will adversely affect the position of the geometry. So therefore, if you scrub forward and scrub backwards, and then scrub forward again, for example, the particles will therefore offset the geometry in essence exponentially. So it will offset it to there, and then there, and there, and there, and so on and so on. So you will end up with an initial set geometry position that looks like a mess. So bear that in mind, please. So obviously, before you close this guy, make sure that you are at frame 0. Okay, so what we're going to do is we're going to set up every single operator first at frame 0, save the scene out, and then play through the sequence. Okay, and before we actually play through the sequence, there is something else that we need to basically do. Alright, so I'm just going to close this now. Okay, go back to my particle view. I'm going to copy this script operator. I'm going to instance it across to here, and I'm also going to instance it across to here and drop that underneath there. Okay, so it's not in this kill, speed and rotation. It's only in the rip out, collision and moving again. Okay, so that is the system set up. Alright, so I'm going to close that, save the scene. Alright, and one thing I need to mention at this particular stage is the way this system is going to basically bake. So like I say, it's going to go through every single frame, okay, all the way up to the end of frame 200. Now the way I've actually set this up in the base scene is so that real time is turned off, so we can see every single frame that's basically going through. Alright, and I've also taken loop off. That basically prevents the system from going all the way up to frame 200 and then looping back round to frame 0, which would also cause the same geometry offset problem that I mentioned earlier on. So once we've actually gone through to the end of frame 200, we need to go quickly back into particle view and turn off the system which we've just created, okay, because the geometry will then be baked in. If however you don't get the result that you want, i.e. you want to go through and you want to change the actual animation of the baked particles, the baked geometry, what you need to do is then either load in the scene which you've just saved out before you perform the simulation, or you need to select all of the geometry, select all of the resulting baked keyframes, which will take a little bit of a while because of a obviously screen redraw issue, so obviously it will take a little bit of a while to select them all, and then also to then delete them. Okay, so what I want to make sure is that real time is disabled, loop is disabled, and then click on OK. And before I actually click on the play button down here, I want to make sure that I've got the correct default in-out keyframe tangent type. I want to actually get this guy selected down here, or this guy here, so that it basically smooths the resulting subframe information, okay, because obviously we're only baking this out at a single frame interval. We don't want a linear one, so if we actually decide to stretch this animation out or contract it later on, otherwise you might get some irregular in-betweening. So therefore what you need to do is have this nice kind of Bechet curve applied here, so make sure you got that selected there. So okay, with all that sorted out, I'm simply going to save the scene now just for safety. I'm going to play through the system. So our tornado is now progressing, these guys are starting to get picked up, particles change colour, and you'll notice that the geometry is now picked up and is rotating around thanks to the spin operators and the transformation matrix in the script. So bounces, hits the deck, and then that's it. Okay, right, do not at this point click on the play button again, don't scrub back or anything like that. What you need to do is go into the particle view, turn the system off, and then we can go and scrub back and forth to our heart's content. Okay, so that is the first of the rest of the systems that we need to set up. So what we need to do now is, like I said, that guy is set up, so what we can just do is hide that and go through and do the next one. Now we don't need to go through obviously and reset all of this lot, but we can use a fair amount of the properties in the next system that we need to set up here, which is obviously for our inner posts and beams.